All right, so in this bell work here, we're on journal 30. And I want to start us off with going over some problems we've been looking at in the past week. So I brought up a concept from each lesson that we've learned. So let's start us off with simplifying a expression. So what it's saying here is I'm taking negative 3x to the 0 power and multiplying it with 4y to the negative 4th. So there's a lot of issues going on here that we do need to simplify. Like there's a negative exponent, there's a 0 exponent. So first thing I noticed was this x to the 0 power. We learned earlier on that anything to the 0 power is just a 1. So I can slash that out and replace that with a 1. So this is really negative 3 times 1, which is negative, I'll write it over here. So which is negative 3, and now that's all I'm left here. And this says multiply with 4y to the negative 4th. And so now I can multiply this number with this number. And so negative 3 times 4 gives me negative 12. And then I have the negative y. And so from here, this negative 4, I need to turn it into a positive exponent because we can't have negative exponents. And so to do that, I need to create a fraction. Whenever you have a negative exponent, you can make it positive if you put it in the denominator. So now it's a positive 4. And the negative 12 is going to sit in the numerator. So this is really negative 12 over y to the 4th power. And that's it. So now I have my simplified expression. Because I no longer have negative exponents and I can't bring 12 and y together. So the next one here, I'm multiplying this factor with this. So you do need a FOIL or distribute. So we're going to multiply the 4x with the 4x. So let me just say, when you're multiplying these two, multiply the numbers first with each other and then the x's. So 4 times 4 gives you 16. And then x times x gives you x squared. You just add the exponents. So then we have 4x times 5. So that's just going to be 20x, because 4 times 5 gives you 20, and then there's an x here. And then the next one here, we have 1 times 4x, which gives me 4x. And then 1 times 5 is just 5. And so looking at this, it looks like these two can be combined. 20x and 4x are both x to the 1st power. So if I add them or combine them, I get 24x. And then I'm going to bring down everything else, like the 16x squared and the 5. And so looking at things, this is a square, this is x to the 1st power, and that's a constant. So I can't combine any further because they are no longer like terms. So this is my final answer. All right, and last but not least, let's review what we learned on last Friday. So when you're graphing and you need to describe the characteristics here, first off, this is a cubic equation. So when you have a cubic equation, there are a few components here. So a cubic equation has an inflection point, which is the middle part of the curve. And so one side will curve up and the other side will curve down, creating this squiggle type of curve. Or sometimes people think of this like as a unravel paperclip or like a thunderbolt. But basically one side will be up, the other side will be down. Sometimes it's the flip-flopped. Sometimes it could be up first and then down. But the middle part, like I said, is your inflection point. And so when you're looking at this equation, you have a plus 3 here and a plus 2 here. So that plus sign in the middle is telling you your shift. So this is shifting 3. Oh, I guess I don't need to write shift. This is going to be shifting left 3 and then up 2, since there's a positive 2 on the outside. And so looking at this, if we're going left 3 and then up 2, that's going to be right here. And I'm going to plot my point and name that coordinate. So it looks like this coordinate is negative 3, positive 2. And I have my inflection point. Now what I'm going to do to grab more points, because you need 3 points to make a cubic function or cubic curve. So you're going to need the slope. So the slope here is the number in front of x. So that's going to be -1, and we always make the run 1 when we're dealing with cubic or quadratics. So this says that it's -1/1 or down 1, right 1. So if I go down 1, right 1, that hits about right here. But then I have to go the complete opposite direction. So instead of going down 1, I have to go up 1, left, and then plot my point. So it looks like this is curving down, and then this side is curving up. And so there is my cubic function. And remember that the domain and range for cubic functions are actually all real numbers, so I'll just put that in. And then all I'm left with is figuring out the y-intercept. So the y-intercept can be calculated if I plug in 0 for the x, and then I just have to find y. So if I'm looking for y here, I have to plug 0 into this equation and then work it out to find my y. So that's going to be -0 plus 3 cubed plus 2. So then that's going to be -0 plus 3 gives you 3. And if I cube this 3 here, because you got to do exponents next, so it's parentheses, then exponents. So 3 cubed is 27, because that's like 3 times 3 times 3. And then there's a negative sitting outside for this 27, and so this is -27 plus 2, which is -25. And so my y-intercept is 0, -25, which you don't need to graph on this since it's so far down. You just need to calculate the y-intercept, and we have. So that's it. So just as a refresher, cubic functions look like this shape, and you have to use the shifts to figure out the inflection point. You're going to need to grab the slope by grabbing the x coefficient, and then the run is always 1. Cubic functions domain is always all real numbers, so that's kind of easy and nice to remember. All right, let's head into today's lesson. So in today's lesson, I want to talk to you guys about the degree of function again and how we're going to be using it to find the number of solutions. So let me just start off with the degree of the function is your highest power in your equation. So in this case, this x is the only thing that's here, and this x is to the first power. So in that case, my degree of the function is 1. And if you go back to how you graph something that's x to the first power, when you have something x to the first power, it's a linear function, or it makes a line. And so that goes back to, figure out what's the slope, what's your y-intercept, plotting 2 points, and then connecting the dots to make a line. So if you were to graph this starts at the origin with a slope of 1, and so it's going to look kind of like this as your line on the graph. And when you're looking at this graph here, the x-axis tells you your x-intercept. Notice how this line crosses the x-axis 1 time. So there's only one solution here, or one x-intercept. And that means that because you can actually see it on the graph, there is one real solution. So with linear functions, you have one real solution, at least for this scenario. And then if you have x squared, the degree of the function is 2 because that is your highest power. So in this case, my degree of the function is 2. That means I'll have at least 2 x-intercepts. And so like if I have a graph or if I have an equation like this is x squared minus 4. This minus 4 is telling me the vertical shift, so this is going down 4. And then I would plot my vertex, and this is pointing up, by the way, but you don't need to know that. But when you graph this, it looks kind of like this. And notice how it has 2 x-intercepts here, and because you can actually see it, these are 2 real solutions. And then I have my last one here. This is x to the third power. And so when you have something that's x to the third power, the degree of the function is 3. And then if I were to graph this, this is going to be a cubic function, so it's that squiggle or that thunderbolt curve. And so again, this has a minus 4, so we're shifting down 4 units on the y-axis. So I'm going to draw that point. I'm going to plot my inflection point, since that's the middle part of the cubic function. And then I'm going to use a slope here. The slope here is 1, and it would be 1 over 1. So you would go up 1, over 1, and then down 1, over 1, and then you would graph your cubic curve. And so there we have it. I want you to notice with this cubic curve, you only see one x-intercept on the graph. So there's only one real, one real solution. But hang on, the degree of the function, the highest power on your function, tells you how many x-intercepts you should have. So in this case, we should have 3, but we only see 1 on the graph. So that means that the other 2 that are missing, so if you subtract 1 from 3, you get 2. That means there are 2 imaginary solutions. So basically, you're going to look in the graph and see how many real solutions you have, and then you're going to subtract from your degree of the function to figure out how many imaginary you would have. So like with these, you have a 2 here, and if you subtract the 2, that means you have 0 imaginary. So these 2, you don't have any imaginary solution, and that's perfectly fine. Most of the time, we don't have imaginary solutions with these linear function or quadratic. So let's move into a few more definitions that I need to mention about. So let's talk about end behavior. End behavior is just describing what is happening on the left and far right side of the function or the curve. So when you're graphing, you need to look at the left and right side of the curve and figure out which way is it curving up or down. So you're just going to describe, is the left pointing up or down, or is the right pointing up or down? And so we're going to describe just x to the third power. Now, we've graphed x to the third power before. So if you remember, x to the third power has an inflection point on the origin and has a slope of 1 over 1. And so it kind of looks like this, where the positive side, it's curving up, and the negative side of x is curving down. So in this case, we're going to describe the end behavior. So end behavior is talking about the left and the right. So watch how the left on this side here, so this is the left, far left side, is pointing down. So that means left is pointing down. And then the right side here is pointing up with an arrow. So this means that the right side is up. And that's it. I have described the end behavior. So end behavior is really easy. You just look at which way is the left and right hand side pointing. It can definitely help if you put some arrows on your curve so that way you can see which way it's pointing to. All right, let's do some homework problems here from packet 6, page 4 and 5. So like I mentioned in the last slide, this is packet 6, and we're going to be looking at page 4 together. So I chose 2 problems for us to look at, problem 1 and 2, and I will also be showing how you can use Desmos to help you graph some of these equations. So if you go to my Google Classroom, you will find the Desmos link, or you can just type into Google search Desmos graphing calculator. So before I show you how to do that, let's go over a few things that you could do without a graphing calculator. Like the first part here is going to be asking you the degree of the function. So the degree of the function, like I said before, is just your highest power or highest exponent. So in this case, the highest power here is this 3. So my highest power is 3, which tells me I should have 3 x-intercepts. And then the leading coefficient is the number in front of the highest power. So if this is x cubed, the number in front of x cubed is actually a 1, right? The coefficient there is 1. So that's a 1. And then this one, they've provided us the graph already. So all we need to do is figure out how many real solutions can we see on the graph. In other words, how many x-intercepts do we see on this graph? And I see 3 real x-intercepts. So that means there are 3 total, and the x-intercept here, the degree of the function says there should be 3, and there are 3 that I actually see. So that means there are 0 imaginary ones. So 0 imaginary. And then when it just says to describe the graph's end behavior, that's talking about the left and right end behavior. So like which way is it pointing on the left and right side. So looking at this graph here, it looks like the left side's pointing down and the right side's pointing up. So left is down, right is up. And that's it. So the hard part here is really getting the graph, and you need to use technology to get there. So you either using a graphing calculator or you can use Desmos, which is what I'm going to show you here in a moment. So let's first grab the degree of the function and leading coefficient. So the degree of the function on number 2 is 5. So in this case, I should have 5 x-intercepts. And then the leading coefficient here is the 2. So it's 2 here. So in this case, this needs to be 2 since it's next to the highest power. And then I need my graph. So let's turn this camera. All right. So what I'm doing is, this is my laptop. And I'm going to show you how you can get to Desmos. So if you click on like my Google Classroom, let me turn this down. There we go. We can see that a little bit better. And so you're going to click on classwork. And then I provided you the link right here under resource link. So if you click on Desmos graphing calculator, so that link should pop open, and then it'll direct you to Desmos graphing calculator. And in here, you're just gonna type this in. So I'm gonna type in the equation that I have. So let me set this screen to the side here. So I need to type in this equation. So 2x to the 5th power, but I need the y. So I'm gonna type in y equals, and I'm doing this on the keyboard. Like I literally typed in y and an equal sign. And so then from here, I need 2x, so 2x, and I just, are typing it from the keyboard. And now I need to the 5th power. And so to do that, you're gonna need the caret button on the keyboard. And so you have to hit shift, this button, and the 6. That's the caret symbol that you see on the calculator. And that's where it is in the on your keyboard. So I'm gonna hold shift and 6 to do that. So give me 1 sec. Let me do that over again. 2x. There we go. And notice how it's made into an exponent symbol, and I'm going to put the 5 down, and there we have our exponent. And then I'm just going to come down using the control pad, and then I need to put in plus 2x, and then shift 6 again, squared, and then this is a minus 5x plus 1. Oops. Plus 1. And I think that is it. 2x and yeah, that looks good. Okay, I'm going to show you what the graph looks like. So there's the Desmos graph, and I want to show you some really cool features using Desmos. The nice part about Desmos is that the zooming feature is so intuitive. Like the interface is so nice. So I can zoom out, I could zoom in if I wanted to see those x-intercepts a little closer. I can even click on the curve, and it will tell me what, where I'm at on the curve. So that's super handy. So I'm going to zoom out just so I can see the max and the min here. So it looks like this curve is curving, looks like this part's down first and then it swings back up. So I'm going to literally just copy this image onto my homework. So let me pause this front camera. All right, so I'm going to set this to the side here. Literally, I'm going to just copy what that looks like onto here. And so, oops. So it looks like it's down, then swings back out, and then up. And I'll put some arrows at the end. So it looks like I have 3 real x-intercepts, and it looks like they've already written that. And they said 2 imaginary, and that's just because there should have been 5 x-intercepts, but 3 of them were real, so that meant that 2 left over were imaginary. And so now I have my my x-intercepts, and I've labeled which ones are imaginary and which one are real. Last thing is the left and right end behavior. So the left side, it looks like it's pointing down, and the right side looks like it's also pointing up again. And so in this case, left down, right up. All right, and that's it. So I want you guys to play with Desmos. If you're having trouble with the homework, use Desmos to help you out, so that way you can get all those graphs in. So I hope this helps. All right, see you later, guys. Bye.